Okay, problem solving related to mass spectroscopy and other. The mass spectrum of hydrocarbon displays molecular ion at m by E 92. The NMR spectrum has two singlet at about delta 2.2 and delta 7.1 in the ratio of 3.5. So this is the possible structure for the compound with region. Given M by A equal to 92, singlet 2.2, singlet 2.2 aromatic CH3 group, singlet delta 7.1 aromatic hydrogen and monosubstituted benzene. Write down the different fragments with their M by E values obtained in the mass spectrum ethanol. Ethanol M by E 45 minus CH2 31 M by E 46 weighs 29 CH2 15. So this molecular formula for the displacement ions obtained from isobutene M by E 43, 28, 27. The formula of isobutene is 58. Difference between the molecular weights of isobutene and the first fragment 58, second fragment 43, 15, it is equivalent to CH3 unit. The difference between the molecular weights of the first and second fragment 43, 28, 15, again CH3 lost. The difference between the mass of the second and third fragments 28, 27, 1, thus 1 hydrogen is lost. Discuss the fragmentation pattern of 2-pentane. Mass spectrum of 2-pentane shows M by E peaks at 70, 55, 41, 39, 29, and 27. The formation of signals is explained as under. 2-pentane, 70, minus CH3, M by E 55, minus CH2 CH3, 41, minus CH3, CH double one CH, 29, CH2 double one CH, 27. The mass spectrum of the hydrocarbon shows the abundant molecular ion at M/E 120. IR spectrum of the compound shows that it is the aromatic in nature. PMR spectrum exhibits three signals at delta 1.2, 2.8, 7.2, 5 hydrogen. Work out the structure of the compound. The molecular ion has the value of M/E 120. It means the molecular mass of the compound is 120. The molecule contains a benzene ring. The mass of the side chains can be calculated by subtracting 77 from 120. It comes to 43. The side chains thus could be C2H7. The possible structure are structure first and second. Also, the possibility of the compound being disubstituted. The possible structures. Structure first and third are ruled out because each one of them contains four types of protons and thus would give the four signals, which is the inconsistent with the data. The only structured second is left. This structure has 6 protons of the one type methyl protons and 1 proton designated B of the second type and the 5 rings protons of third type. Six methyl protons gives about delta 1.2 due to splitting by protons. B1 proton designated B gives a multiplet delta 2.8 due to splitting by the methyl protons, and 5 ring protons give a singlet delta 7.2. All the observations made with the structures second agree with the data, hence this is the correct structure. A compound containing C, carbon, hydrogen, and oxygen exhibit molecular ion at M/E equal to 7. Its IR spectrum shows a strong band at 715 per cm. PMR spectrum shows a triplet, singlet, and a quartet at increasing values of delta in the ratio 3:3:2. What is the structure of the compound? Since the mass spectrum of the compound exhibits molecular ion at M/E 72, the compound has molecular weight 72. The IR spectrum shows an absorption peak at 715 per cm. The characteristics of a carbonyl compound. It could be aldehyde or ketone. Possible structures with molecular mass 72 are as follows. Structure first contains 4 types of protons. It would therefore give 4 PMR signals, which is inconsistent with data, and structure first is ruled out. We would expect a doublet or multiplet and again doublet from the structure second, and this structure also ruled out. Structure third is the only the structure left. 3 protons on carbon 4 will give a triplet due to splitting by protons of carbon 3. Singlet will be given by protons on the carbon first. There will be no splitting. Here again 2 hydrogens on carbon 3 will give the quartet due to interaction with the protons of carbon 4. Thus the ratio of various peak intensities is to 3 is to 2, that is in the ratio of the hydrogen atoms forming the peaks. If we consult the table of PMR chemical shift, we find the values of delta in increasing order. Thus, these observations are in the conformity with the data. Therefore, the correct structure is the third and often the three peaks. A hydrocarbon shows a mass parent ATM by E 102. It exhibits NMR signals delta 7.4, 5 hydrogen singlet, delta 3.08, 1 hydrogen singlet. What is the probable structure of the hydrocarbon? Mass parent peaks at M by E 102 shows that the molecular mass of the compound is 102. NMR signals show that there are two types of protons, 5 protons of one type and 1 protons of the another type. 5 protons are possibly the protons of monosubstituted benzene ring. The size of the side chain can be calculated as follows: 102 minus 77, 25. Mass of the compound C6H5 side chain compound, a value of 25 mass suggests that C triple bond CH. This is varied from the NMR spectrum, which tells that the second singlet is due to hydrogen only. Thus, the structure of the hydrocarbon is singlet. This is the phenyl acetate. An aromatic hydrocarbon C8H10 shows two singlet in the PMR at delta 2.3 and 7.05 with proton counting in the ratio of 3 to give the region assigned structure to it. There are two possible hydrocarbons with the formula C8H10 as given below. Structure first would give the three peaks as there are three kinds of protons in it. Structure second would give the two signals as there are two kinds of protons. It may be noted that the 6 protons of the two methyl groups are equivalent. As the compound under the examination gives the two peaks, it can be only second. The peaks at delta 2.3 correspond to the methyl protons and that delta 7.05 correspond to ring hydrogens. There are 6 methyl protons and the 4 rings protons, thus they are in the ratio 6:4 or 3:2. This ratio agrees with the given value. Thus, the structure of the hydrocarbon is. How would you differentiate between the methyl methoxyethane and ethenoxyethane? Using the IR, both the compounds would give an absorption band at around 1700 per cm due to the carbonyl group. Ethenoxyethane would give an additional band between the 3000 to 3100 per cm due to the double bond. The compound methoxyethane has no conjugated double bond, hence it gives the absorption band below 200 nanometer. The compound ethenoxyethane has conjugated double bond in the molecules. Such compounds give an absorption band above 200 nanometer. This is how compounds can be differentiated. Indicate the expected important absorption regions in the IR spectrum of the following compounds. A compound was believed to be either a diphenyl ether or diphenyl methane. Could PMR spectrum be used to distinguish between these two compounds? How? Phenyl, diphenyl methane. Diphenyl ether does not show spin-spin splitting due to diphenyl methane shows explain ethylene fails to observe at 1600 cm in the IR spectrum. It contains a terminal hydrogen atoms linked to the carbon so that ethylene fails to observe at 1600 cm in its IR spectrum. How would you distinguish between the 3-dibromobenzene by the NMR spectra? Ortho-dibromobenzene will show 2 peaks, meta-dibromobenzene will show 3 peaks, para-dibromobenzene will show only 1 peak. Ortho-dibromobenzene, meta-dibromobenzene, para-dibromobenzene. Suggests structure of consistence with the following NMR data, molecular formula, singlet delta 6.78 3 hydrogen, singlet delta 2.259 hydrogen. How do you distinguish between the following pairs of compounds by NMR spectroscopy? Methyl ethanoate will give only one signal. Propanol will give 3 signal. Propanone will give the 1 signal. Methyl ethanoate give the 2 signal. Okay, it's all about some problem solving related to mass spectroscopy and NMR, IR, UV. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now. Bye bye. See you again.